Okay, I guess this time I'm going to try something a little bit different. Um, yeah, what am I going to do? I'm going to try and show you, I guess, on Leetcode, and I'm going to try doing one of these random sets. And I'm going to, I guess I'm recording this, I'm not live streaming this, but I'm basically going to walk in blind. I have no idea what problem is going to be given. And I guess I want to just see, maybe show you how I approach these problems. Hopefully I don't get stuck, but even if I get stuck, maybe it'd still be a good education experience. So let's just give it a try. Okay, so there are 4 questions, up to 2 hours. You cannot pause the timer, so let's start. So the way Leetcode works, they give you a problem and you're going to get a solution that's written in, if you're doing C++, it'll be a class, and you have to figure out how to write this function. But because it's a class, you can use class member variables and write private functions and so on. Okay, so what is this problem? Given the root of a binary tree, check whether it is a mirror of itself. So if you have a tree, 1, 2, 3, follow up, could you solve it both iterative and recursively? Number of nodes is between 1 to 1000. Each node is between minus 100 to 100. How is this tree represented? The definition of a tree node, left and right. The input doesn't look the same. The input here seems like it's a list of some kind, but actually the tree is a standard tree. Okay, so how do we do this? Well, of course, if the tree is empty, then it's a mirror, right? Otherwise, we have to be a little bit, we have to figure out what to do. Okay. We probably need some kind of helper function that decide if the left side is the right side, it's a mirror of each other. So who is mirror like this? So what do we do? If not root, so that's if the tree is empty, then that's easy. Otherwise, what do I do? I say return is symmetric root arrow left, root arrow right. So I'm basically deferring all my decision to here. So if I have left and right, what do I do? If I have 2 subtrees and I have 2 trees, one I want to know if the mirror image of each other, then if left, if both are empty, then that's okay. If left, if one of them is empty but the other one's not, I guess. So if either one is empty, then we already know, oops, it's not both empty. Then they're not mirror of each other. Okay. Other than they're both, so now they're both non-empty. so the root have to be the same. So if root arrow val, sorry, not root, left arrow val not equals to right arrow val, then they cannot be mirror. And then the final thing is the left subtree has to be a mirror of the other one, right subtree, and so on. So return is mirror left arrow left. So when we flip the left branch here, that has to be the same as the other one's right branch. And then vice versa, and is mirror left arrow right, right arrow left. Okay, I think that's it. Let me just think about this. So again, check if the tree is empty, then it's symmetric. Otherwise, if it's not empty, then we get rid of the root, and then we check that the left side is a mirror image of the right side. So how do we do that? If one of them is empty, if they're both empty, it's good. If one of them is empty and the other one is not, that's no good. If the left and right are mirror image of each other, the roots have to be the same. So if they're not the same, it's no good. Otherwise, the left subtree of the left side has to be the same thing as the right subtree, well, the mirror image, and so on. Okay. Should I run it? Let's run the example cases just to make sure. Oh, what did I say? Use of, oh, I didn't type it in right. Any other compiler? That's it. Too many, oh, okay, so I called it wrong. That's what I meant. Okay. Can I run it on a different one? Okay, I'm pretty confident. Let's see. Success. Okay, so that's first question done. Second question, what is the question? Okay, you're given an n by n integer matrix board. Cells are labeled from 1 to n square. In the bootstrap feed and style. I don't even know what that means. What is that? A style writing in which the alternating lines are reversed. Okay. Okay, 1, 2, okay, so that's what they mean. You start on board 1. In each move, start from square curve of do the following. Okay. Choose a destination squared next with a label in the range of curve plus 1. Okay, so choose the result of a 6-sided row. If next has a snake or letter, you must move to the destination of that snake or letter. The game ends when you reach to this end. Okay. A board square on row RC has a snake or letter if board RC is not equals to 1. The destination of that snake or ladder is board RC. The squares 1 and n squared are not the starting points of any snake or ladder. Note that you only take a snake or ladder at most once per dice roll. If the destination Okay, so you do not follow again, even if you have another. Okay, we turn the least number of dice rows required to reach the n square. If it is not possible to reach the square, we turn -1. Okay, so you have a bunch of stuff like this. -1 means you keep going, you just row and so on. N is at most 20. One and n square are not the starting points of any rows and ladder. Why do I even care how they number? Because I'm basically given a graph, right? I can't care less that it goes exact. I know that exactly these are the numbers. It's basically a graph. Yeah, so this is a graph with 36, n square nodes, and I'm looking for the shortest path, right? I do have to be a bit careful about how I construct this graph, but basically that's it. So I'm going to do my standard graph thing. So graph would be a vector. I'm using adjacency matrix as a list. Okay, so G what I do. So n is the size of the board. So G dot resize n square. Okay, I have to remember that now I'm at 0 to n square minus 1. I'm not 1 through n. So I have to be careful with that. And then actually, I'll just do one more, just 1 to n. So for, oh wait, I do need to know, okay, wait, I do need to know the numbering because it's given to me in this board. Okay, so -1. So the first row is actually the top row. Okay, so I have to be a little bit careful here. So let's figure out the numbering of everybody. Okay, so I'm going to have a vector. The labels. And then I'm going to do for n-1. So I'm going to label backwards. And for j equal to 0, j less than n, j plus plus. Oops. So probably how about I do this, and then I'm gonna have big labels. I guess I should use the same convention of function names. Okay, so label dot resize, and I think I can do that. And then for I label ij equals curve plus plus. But now sometimes things are going to be wrong, so if reverse begin label I okay, so like this, and actually just to be sure just make sure that this actually looks correct. What did I do? Oh, I never return anything. Is it an error? Oh, because they... Okay, fine. It's a warning that they compiled it with a flag that makes it an error. Okay, so that looks kind of what I expect, so that's good. Okay, so now what am I going to do? For each node, let's go to V. Okay. Now I need to say, where does it go? There's 6 choices, possibly. The die is okay, and so now the destination, it's the min. So the destination, it's v plus d okay, so that makes sure that I don't have to worry about going out of bounds. So v plus d, but I might have to follow. So now actually I don't need the labels. I need to know, what do I need? I need to know where to go, where it goes to, and what the label is. So I know that this is a label, and now I need to know where the destination is. So what should I do? I should build a destination list. So I know easily, so I'm going to say the destination of the node with that label is what if I get there if it's not -1, then it's whatever it tells me to go, otherwise it's just label ij. Okay, so I don't move anywhere. So here I don't want to call this destination, so v plus t is when I end up, but my real destination is destination v plus t, and graph v dot push back. So that's where I end up going. That's my edge from v to the destination v plus t. So if I have built this properly, then I'm gonna do find distance from 1 to n. And this will basically a preferred search because it's just a graph with every edge. So here basically it will make sure that I go and follow the ladder and the snakes. I guess that changes to the same indentation style. So I'm going to use a BFS. So I don't have n, but that destination is the largest one. The distance -1 means no distance not yet found. So distance source is equal to 0. I need a q as well. Wow. Q is not empty. Then get the front of the cube, pop it, look at the graph, all the neighbors. If dist of w is not equals to -1, that means I've never seen it before. Then I say push w, and distance w is equals distance cur plus 1. That's our standard preferred search. And then at the end, either I found the destination, or it's never even found, and it's still at -1, which is the impossible case. So in any case, I print distance to destination. Oh wait, return. No, I don't want to print, I want to return. I forgot we're doing Leetcode and not caddis. So then this has to be return. Okay. -1, that's no good. Let's do the simple case. -1, so that's no good, but this is a small thing, so we can hopefully easily figure that out. So let's see what edge we decide to add. Okay, so one can go to, so 1, 2, 3, 4. Wait, 1, 2, 3, 4. So the grid is, where can I, is there some place I can type something? So the grid is actually 1, 2, 3, 4, and this has a ladder to 3. Okay, so I'm adding 1 to 3 because that row, that's good. And then 2, I can go to 3, I can go to 4, 3, I can go to 4. So the graph looks right. So what did I screw up on in my find distance? I push cur is okay. Oh wait, oh yeah, I have to change it back to this, that's why. Doesn't push anything. Oh, because I'm stupid. I got reverse logic there. You think that I wrote preface such a gazillion times and I know what to do? Okay. Okay. Success. Okay. That took a little bit longer than it should be. Let's see here. Given a string S in a dictionary of strings word take return true if S can be segmented into a space separate sequence of one or more dictionary words. The same word may be used multiple times. So you have a dictionary of this type. Word length is at most 300. Dictionary length is at most 1,000. Alright, so this is a very standard dynamic programming. So you just try to figure out which word in the dictionary can be the start of that string. If there's none, then you're done. Otherwise, you may have a bunch of choices, match that, and then return a substring. So you need to figure out, for example, here, cats and dogs, so you have to say, well, you can start with cats, but I can also start with cats. So you have two choices. So if you start with cats, you recursively ask, can this be done? And that's where the dynamic programming is. So there is a better way than just doing brute force search for the dictionary if you really want. You can use a data structure called trie to figure out quickly which to store the dictionary, but I'm not going to code that up because this is a fairly small dictionary, so I think we can just do a brute force. So we're supposed to return true or false. Alright. We can either do it at the end, we can do it at the front. Doesn't really matter. Okay, so let's start with some basic stuff. So is the candidate a prefix of the string S? So does something in the dictionary starts, it's a prefix of S because that's important. So the way that we do this is s.find candidate. If it's exactly 0, then it starts there and that's it. Okay, so what we're gonna do is we're gonna have integer. So I'm gonna read a table that stores whether that length can be done. 301 is good enough, and I'm using it's Boolean, true or false, but I'm using -1 to indicate I have not done it. Okay, so n is equals to s.length. So nothing is done. Then I'm just going to say return can break s word date and 0. Okay, so I start at 0. So I guess I'll just make n global inside my class to make it easier. So bool can break So if index it's bigger than n, so if I've gone past the string, that means I'm done. I got nothing left. Return true. So now, oh actually, it's my string going to keep the same, or maybe actually I'm not going to pass an index, I'm just going to repeatedly wait, what should I do? So either I keep shortening the string, so I'm always looking at the prefix I'm chopping things off as I go, or I move the index and I never touch a string. It's more efficient to never touch the string, so my prefix function would probably have to pass in an index. In that case, I have to start searching at the index and it has to match the index. Okay. Otherwise, for each word, in the dictionary, if prefix string and the word and that index is true, and recursively I can do can break index plus word dot length branching. Okay, then I want to return true, and if I can't do it, I return false. But this currently doesn't have any memorization, so if memo index bigger than or equal to 0, return memo index. Otherwise, so this prevents you from doing multiple times. So it's a dynamic programming problem. Let me just make sure the length is at most 300. So everything's set to be -1. I start at index 0. So if I've gone over, I have empty string basically. I match everything, so I'm good. Otherwise, if I've done it before, or for each dictionary word, I ask is it a prefix at that location, and if so, I can recursively break it. Then I return true, and if after I find everything I still don't, if I try all the words and it doesn't work, then it's false. Are there more test cases? True, true, and false. Oh, I meant to hit submit. Okay. Success. All right. Now let's see, what is this last problem? Wait a minute, is it the same problem? Oh, okay, wait, this is a different problem. Given a string S and the dictionary of strings word dict, add spaces in S to construct a sentence where each word is a dictionary. Wait, that's like the same problem, but you have to also construct the actual sequence. What's pineapple pen? I see. So this time the length is only 20. Otherwise, you'll probably have some exponential amount of output. The length of the answer it's not too much, fine. Only lowercase letters. So now the problem is smaller. So basically it's kind of the same thing. So what do you have to return? You have to return a vector of string. And the string is, oh I see, with space added. Okay, so it's kind of the same problem, but this time you have to do it. You cannot do dynamic programming because you actually need to redo. If something is possible, you need to kind of redo them because you actually want all the solutions. So you kind of have to do an exhaustive search. There are some optimizations that you can do if you really want, but it's probably not worth the trouble. So back to string result. Okay, so generate results as predict result. Okay, so I'm gonna do this generate result here. So what does this do? Okay, so this time I'm going to actually physically shorten the string. I think it's easier. So if S, it's the empty string, there's nothing to do. Otherwise, for each word, I have to use const because that's more efficient, but I have to use const auto reference, that's more efficient. So for each word in my dictionary, if s dot find w equals to 0, okay, not equal to 0, I skip it. Okay, so there's no, it doesn't, so now if I'm here, W can start this, so I need to recurse generate results, but what do I generate? I need s dot substring, basically get rid of that much, so I get rid of the first part. I still have the same dictionary. Results, but I need to know that I got this word in this. So actually I need some vector of strings to build up my answer for that particular answer. So what do I call it? I'll call this word split. So what I need to do, word split dot push back W, and this I have to undo. But here, instead of returning, I actually need to do something. I actually need to take my word split and add it to the result. So I need to build a string of answer equals to the empty string to say answer plus equals to word split I, but I have to put a space. So if I is greater than 0, I need to put a space. So only put it not before every word, but before every word after the first one. And now I build a string, and then I have to say result dot pushback. Okay. And just to make things a bit more efficient, so because I'm going to push back and pop back all these things, I'm going to reserve, so make to avoid resizing all the time. The length is at most 20, so you can never have more than 20 words, I guess. And then result well, 10 to the 5. So at most this much. Just because pushback can resize and then maybe reallocate, that could be slow, but if you reserve it, then you allocate the big chunk at the beginning, so you don't have to do this all the time. And I think this, did I return anything? Let's see. That looks like it's in different order, but it says in any order. Okay, that is right. Pen, apple, pen, apple, pen, apple, pen, apple. That looks right, and the last one is empty. Okay, finish. Let's see what it says. Anyway, so I mean, I kind of try to do a live blind test to show you what I would do when I see a problem. I know that I didn't go through every problem slowly. I kind of normally I would go through it in a little bit more detail and explanation, but basically now you see how I do it. I did probably stumble a little bit in the snakes and ladder. I probably should have thought a little bit more before I tried it, because at some point I had to figure out what I want to do with these labels. Word break 2 is hard, actually. I thought that was the easiest problem. And then also word break, and both word break and word break 2 has a dictionary, and I'm basically brute forcing to see which dictionary words can match at the beginning, but there's a data structure called a trie that allows you to store dictionary, and you can search very quickly. So for example, this, you start with a root node, and then TO, this path represent 2, and then if you have a word T, tat, and so on. So if you want to know if if you have a string and you don't want to know if TO it's part of it, you just start from the first letter and follow down the tree, and when you reach, if you reach a terminal node, you know that's one of the possible matches, and you can basically do the search in linear time once you build this trie. But since the problem was so small, I didn't bother with that. And then, yeah, the second one, what do people do? Okay, maybe I should actually look at what, if I go to these problems, would I be able to find other people's tutorial? Is that a tutorial? Subscribe to unlock. No, I don't want discussion. So change the title of the question to mirror tree. Blah blah blah. Okay, this is basically what I did. So even after you do it, you probably want to take a quick look to see if the other people do it in a different way. Yeah, DP doesn't work because they could be going backwards. I don't know, maybe there's not much more to say. Classic BFS. Apply to convert to linear array and forget the board. That's pretty much what I did. BFS, blah blah blah. Word break. So even if you've done it, it's probably a good idea just to browse and see whether you have done anything that other people have done it differently, in case you learn something. I don't know. Use dynamic program. So this is what I did. Word break 2. Well, I never use DP because the problem is so small. I mean, you can use DP if you want. So instead of saying true or false, like in this, so in the second version, so the third problem, instead of just returning true, saving true or false, you can actually save a list of words, a list of indices that can start that string. But since oh, there's a video. I don't know.
Let's find it.
Just do
Set temp to an empty string, because we're going to use temp to construct our subproblems. So assuming we had just so looking at this particular iteration, would include append VEG to everything inside there, which is just an empty string in this case. So that's why we get VEG here. And then that's what's going to be set.
You can use DP. I know that you can use DP to make things a little bit more efficient, but I didn't think that it was necessary to make things more complicated. But anyway, so that's that. So, but doing something a little bit different today, this week. Now you can go and try these problems. You can go to, if you just go to the problem list of Leetcode, you can look up, for example, symmetric tree, and you can go and try it, right? So can I actually show my submission anymore? Oh no. Okay, yeah, I can get my submission back. Anyway, so that's that for this week. And go and try it and let me know if you have any trouble.